Team, this is a little review between resistors and capacitors. I wanted to make sure that you know the difference. So let's start off with the first problem. In order for us to identify that it is in series, we use this equation. And series here is R1 and R4. In order to identify if they're in parallel, we use this equation. Parallel. In this side it is R2 and R3 that are in parallel. So first step to solve this figure from A to B, let's start with step 1, and that is parallel. Let's go with the parallel first, just so we can get rid of them. So it is 1 over R2, 3 equals 1 over R2 plus 1 over R3. In order to find the inverse of that, so we can just get R2, 3, it is R2, 3 equals 1 over R2 plus 1 over R3 to the negative 1, which we'll be able to flip this one. So now we go to step 2. Step 2 is solve in parallel. Solve in series. Solve in series. And at this point, we should have a figure that looks like this. Where this is R1, this is the equivalence of R2, 3, and this is R4. Notice now that all three of them are in series because you converted this one into just one resistor of equivalence. Okay, so all you have to do is, when it comes to series, for resistors, it is summing them up. R1 plus R2, 3 plus R4. And that is your answer, your algebraic answer for this problem. Okay, now let's go for 2. For 2, it is capacitors. Capacitors, it is a little bit different. And in capacitors, we have this equation, where this equation means parallel capacitors. This equation right here, it is series capacitors. So again, always start with the parallel ones. Step 1 is parallel. In parallel, C2 and C3 are in parallel. So using this equation right here, C2, 3 equals C2 plus C3. Done. You're done with the parallel. Now let's go to step 2. Step 2, series. So now it should look something to this effect. C1, C2, 3, and C4. Because this is converted into one equivalent capacitor, that equivalent capacitor is C23. Okay? Because they are in series, we have to use the series equation for capacitors, which is 1 over C equivalence over equals C1, 1 over C1 plus 1 over C23 plus 1 over C4. And in order to get the inverse of this, to get it like this, just make sure that you put this to the power of -1 to find the inverse. And voila. That is the answer for your algebraic answer for capacitors. And this concludes this video for our review in resistors and capacitors.